Hello, hello. Good day, everyone. We are back for more OCaml, for more cast development, for more rewriting of the entire thing. Okay, OCaml, we are rewriting cast parser and improving. Okay. Cast is a programming language. Okay. We open VS Code. I was doing a little bit of work off stream because I'm addicted to OCaml, of course. Right? And I was doing stuff. So what did I do? What did I do? First of all, I made the thing. So we have so far the lexer and the parser, which I was working on yesterday, and then I like fixed a couple of things. And then I made, so we have the cast binary now. I mean, not now, but previously it was just hello world, but now it's actually is a binary, right? So this is just running the main thing here, and this. So yeah, so help is not implemented, but we can do basically tokenize. And tokenize is just for testing the lexer, basically, right? So here we go. Here's my example, hello world, right? Written in cast. And these are all the the tokens that we get out of it. I figured out that VS Code supports this notation, which is called the GNU range, GNU style ranges. I don't know where it's documented. I don't know where it's documented, but I found it in one of the change logs on VS Code, basically. So what this allows me to do is that I can click on this thing in the VS Code, and it actually will select the entire thing, right? So it's not just a line and column, it's an actual span. So the line 1, column 1, line 2, column 2, we can click on this, and it selects the entire token, right? So we can like check that it's been tokenized properly here, right? And similarly to that, we can do cast parse. So parse is the one that is doing the next step, which is the AST. So I made sure that it works, and it does the same thing, right? So we have this is the entire program. The entire program is the then node with 2 fields. First we use the std star, right? So this is my std, this is the entire use std star. This is me applying hello to world, and this is me piping world to print, right? So this is all being parsed successfully using the standard syntax, or default syntax is what I call it here, right? So default syntax is being written like this right now. Right, so I have only implemented the things that are enough to parse this hello world here, right? So we have the syntax that defines the then, which is the semicolon. We have statement which is just a trailing semicolon basically. The use star, right? And an if I guess is not used there. A pipe, apply, and scope, which is just a parenthesis. So this is allowing me to parse. Now this is still a little bit too verbose, right? Obviously in the language itself, we don't specify this in the OCaml code. We want this to be specified in the code itself. So I want to work on that and making sure that it's actually the extensible syntax, so we can extend the thing while parsing, right? Which should be relatively easy, and then like do, and then we already have some cast code which we can just test that it parses correctly from the old version that's written in Rust. Okay. Yeah. So I also have like the tests. Yeah, I also have like this bug, I guess, right? So we have a test that should not even parse over here. Oh yeah, that's another thing that I did, right? So if for the tests to work, right? How do I specify what is expected here, right? So this is what I call the simple syntax here. So simple syntax, right? We basically translate our entire program from like the complex language into a simpler language, which is it's not exactly a Lisp, right? But it's very close to a Lisp. So what we have here, like we have basically like a application, which means that this is like a complex syntax node named apply with these arguments, right? And then the arguments can also be named, right? Where in Lisp, everything is just an unnamed list. And in list, like just the first element of the list is the function that you apply, right? But I make it like outside of the parentheses. That's the only difference. Otherwise, it's basically a Lisp. So in order to parse this, I made another syntax, which also uses the same parser, right? So the same parser, but a different set of rules, right? And these rules are very, very simple. We can we just have like commas and named fields and the actual application, like specifying the complex node. So I use the simple syntax to actually write the tests. Yeah. So this over here is actually a bug because this should not even parse, but this parses into F, right? Yeah. So it says that we parsed F, which is the identifier. So why does this not succeed? Because the parser is not checking that we, after parsing, reach the end of file, right? So we, yeah, like we made this progress and then the parser didn't know what to do next. We need to check that it's the end of file. So yeah, so parse should basically check. Parse should basically check that we are at the end of the file here, right? So we do this is my result, right? And then I say that let peak is Laxer peak, right? And then I say that match peak value in with. So if it is the end of file, then I return result. But if it's not the end of file, if it's something else, then I will fail with. I will fail with something. Fail with what? I think I need to like change my formatting rules. So far, I did one OCaml format thing, which says that I never should break string literals. I feel like I want to customize the formatting a little more. Like, for example, this over here, I don't even want it. I never want the matches to be on the same line, I think. Like, I feel like this always should be indented like that. But then it's automatically replacing it. You know what? Actually, I should look at that. Camel format options. Where should I go? Documentation. Easy fix, don't do OCaml. Why? No. OCaml is cool. OCaml is nice. OCaml is great. We love OCaml. Love everything. But OCaml especially. Right? We just need to ignore the annoying parts of it, and then it's fine. And it's cool. And then it's good. Getting started. Configuration. The full options documentation is on this page, which is just the main page. All right. So I want something about the matches here, right? Break cases. Break pattern match cases. Specifying fit. Let's pattern matches break at the margin naturally. So there's a fit, nested, top level, fit or vertical, vertical or all. Okay, what's the default one? The default one is fit. So fit lets pattern matches break at the margin naturally. Nested forces a break after nested or patterns to highlight the case body. Note that with nested, the indicate nested or patterns option is not needed and so is ignored. Top level forces top level cases, which is not nested or patterns, to break across line. Otherwise break naturally at the margin. Yeah, I think I actually want the top level. Yeah, top level makes sense. Are you positive OCaml will compile faster than Rust? Yeah, pretty positive. That's what the like. It's a simpler language. Yes, there are some parts. I mean, like one of the things, for example, that a Rust's type checker is doing is it's searching for the trait implementations. OCaml doesn't have that feature, so it doesn't need to do it. So, like as one example, and in general, like this will compile more times than Rust. That doesn't matter. Like the fact that you cannot like is that a good thing though, right? Like the fact that it's compiling more times than Rust. I guess you mean that the Rust will complain at you more because of like the borrow checker, and you will like rage because of that. That's not a problem. That's just a skill issue. I mean, like experience is what's needed to fix that. And it's a good thing. In Rust, the fact that it doesn't compile is good when it's wrong. Like wrong code, I don't want the wrong code to be compiled. So that's a good thing. I would prefer maybe in something even stronger than Rust. That's why I'm making my own language, Cast, right? It's supposed to even reject even more code at compile time, which is obviously wrong, right? But the compilation times is a problem indeed. Like that's why I don't go into Haskell, for example, because Haskell is compiled even slower than Rust. Not in my experience, because I haven't built big Rust, big OCaml or big Haskell projects, but like according to the internet. OCaml is basically blazing fast to compile. That's what the internet says. And Haskell, because of its like extensive type system, because of all of the checks that it needs to do, is pretty slow. Like languages with dependent types, which would be like even stronger than Haskell, they compile even slower, which makes sense because dependent types, like allow running any program at compile time. Like I'm wondering like if people actually like how like Zig allows you to run arbitrary code at compile time, right? So technically, you can make it compile really slow by running some really slow code at compile time. I'm just wondering how like if you really abuse Zig's comp time, you can make Zig compile really slow too, right? When we just like make a hello world in Zig, or I don't know, like make some simple program, it's not a like you're not going to feel it. So I'm just wondering, how does Zig actually work on like big projects? Maybe you actually like in order for Rust to compile fast, I need to not use certain Rust features too much, right? Like generics, because generics slow down the compilation times. So like similarly to that, maybe like when you write code in Zig, eventually at a big enough project, you need to not write comp time code so that it doesn't slow you down. How does OCaml do traits interfaces? There is no equivalent. No, the equivalent is explicit thing, which is called modules. Check out Ghosty. Ghosty is the terminal. I don't know like if terminal is a big project though. How many lines do they have? Like I don't know if this can be considered a big thing. Really, where is the source code for this? Maybe like in the actions we can see it. There's prettier build Flatpak, so like 50 seconds. Build Linux 40 seconds, right? Test build. Well, it looks like 34 seconds, right, for this one. And I don't think that like a terminal emulator is a big project. I mean, it's a big project, obviously, like relatively, but it's not the biggest project ever. And it's already at 34 seconds, right? I'm just wondering, does that include the dependencies? Or is it just that code? I don't know. Maybe 34 seconds includes downloading dependencies. Probably not though, right? I don't know. Anyway, we're not going to do Zig anyway. But so for Rust and traits interfaces, the alternative is the explicit like. So basically, an interface. Like for example, you want to sort an array, right? Let's take a look at this. So you want to sort an array, list, or I guess list sort, right? What is the signature of this function? The signature of this function is having a list and the comparator, right? So you need to always supply your comparator explicitly, which is the annoying part of OCaml, right? You cannot just have A where A implements the ORD trait. You need to always supply the implementation of the ORD trait manually. Sometimes in terms of a function, sometimes in terms of a module or some sort, right? For example, we have the so for I make a string map, right? So what's a string map? A string map. This is like kind of like a generic. Hold on. Yeah. So like it's modules and functors. I don't know. I don't want to like go into too much details about this, but it is very, very explicit. It does make sense for a type to implement ORD. Why not? Like, it's good to have an option to specify the comparator explicitly. How do you sort a string? No, ORD is not about sorting. How do you compare a string? ORD is about comparing. How do you compare a string to another string? Well, you compare it lexicographically. Or I guess, like, if you don't like the fact that lexicographically comparison is the default, then maybe, like, in your language, you don't have the implementation of the ORD for string, so that you can only sort. But for some types, there is an obvious implementation of a trait, right? And then, like, it is implicit. That's how it's done in Rust. That's how it's done in Haskell through the type classes. In OCaml, it's always explicit, right? Think about printing, right? For example, printing. In Rust, we have the debug or display traits, and in OCaml, it is basically, like, I need to explicitly, like, over here, right? This in Rust would be something like this. Like, you know, this is like write fmt basically, and you know, name is value. I just write this in Rust, you know, but in OCaml, and to specify how exactly the value needs to be printed, right? Which is the function print value. So similarly to the sort function, I need to supply the comparator. For printing, I need to supply the printing function for generic things. For some things, it's like %s. I don't need to do this for name because it already knows how to print strings. But in general, it doesn't know it. So A is like the generic print instruction, which needs to have the printer supplied, which makes it more verbose and kind of a little bit more annoying, you know. But like, it's a good and a bad thing at the same time. Being explicit means that I can change the printer, right? Like one thing that you cannot do in Rust is you cannot temporarily change the implementation of a trait, right? For a type, there is only one implementation of a trait. But in this case, you can, right? But it is a more explicit thing. I kind of want to have both. And as far as I understand, even OCaml, even in OCaml, there is a proposal to make it less explicit. It's called OCaml implicit module implicits, modular implicits, but it is not implemented in the language. Are we going to merge this into master? Like, or maybe, like, it's actually there from 2017. Maybe, like, if maybe I can, like, I grab a specific branch of the OCaml compiler that has this implemented. But yeah, basically it is implicit, like an implicit argument. I don't know. I haven't, like, looked at specifically this, but as far as I understand, it's similar to what I'm going to have in my language, or what similar to what, like, a Scala does. Scala has also, like, implicits for the same reason, basically. Contextual parameters, implicit parameters. So, like, if you have the comparator, right? So this is, once again, this is a maximum function in Scala, but you can think about it as a sort, for example, too, right? A sort is the same stuff. So in order to sort a list, you need a comparator, and this over here is like a separate set of arguments, which is called implicit argument, which is going to be passed to your function automatically. It just needs to be in scope, basically, right? So when I call a function which requires a comparator, I just need the comparator to be in scope. That's the entire thing, and that will allow us to have basically the alternative to traits, which is like they are implicit arguments, so it is implicit, similar to traits, but at the same time you can also override it, which is something that you cannot do in Rust or Haskell. Yeah, I mean, you can do that in Rust. It's with a new type, but that's very annoying. You don't do that really, right? So yeah. But yeah, this proposal for OCaml apparently is from like 20 years ago, and it's still not there in the thing. Okay. Yeah, I need to. I was doing something. Yeah, over here. So this should say, so when I parse the source, and I have parsed the thing, and I cannot do any more progress, and I am not at the end of file, then I should fail saying that unexpected peak, which is spend print. Yeah, and over here I see I'm trying to print the peak token, right? So the token that is in front. So it says because this is a spend token, I need to specify how do I print it. So I print the token. You see how explicit this is instead of just printing this? Yeah, I think maybe I will actually get used to this. We'll see. So yeah, this now says that we have unexpected if at 1 3. Oh, Nerdzel. Nakilon. Is it like no OOP in OCaml? No OOP in OCaml. No, OCaml actually has the OOP, but nobody uses it. There are classes. So I guess you can do interfaces with that, but as far as I understand, nobody actually uses that. Also, Vikrant said, please make sure that you don't create an unwrap hell. Does anyone think that there is an unwrap hell in Rust, though? I feel like Rust doesn't have the unwrap hell. Unwrap hell. The external print would call the message to serialize to string or debug. Yeah, you could do that with objects, but like once again, it's like nobody uses them in OCaml. Why? I don't know. I don't think unwrap hell is a thing. Unwrap hell is a feature. Yeah, I think it's a feature. That's a good thing. Unwrap hell is a good thing, but I just wouldn't call it hell, basically, right? It's heaven. It's the unwrap heaven. Unwrap and clone heaven. All right. So yeah, this is the test. This test is failing. Maybe we should say like test that it should fail to parse. Unless you want to debug. I want to debug, I unwrap. What's the problem? Like unwrap makes you actually, it makes it easier to debug. Right? I mean, compared to what, I guess? In other languages which just have the nulls, you just have null pointer exception, which is basically like an implicit unwrap is happening under the hood in those languages, right? But compared to a language like C++, you get segfault instead, and you don't want that. You cannot easily point which unwrap. You can. What do you mean you cannot? You can. I don't know what you mean. If I say none dot unwrap, then it will say that I unwrapped at main line 2 column 17, which is like this unwrap. It's pointing specifically to this unwrap. You can have the full backtrace if you want to. You can easily point to a specific line of code which panics. I'm not sure what you are talking about. So yeah, we test failed that this source is failing like this. You know what? I'm just going to pass a string here. So we have two tests. The test like that. And the test that should fail. It's called should fail. Source string. So yeah. I just say parser parse, and then I say try, and then I catch an exception here. Which kind of exception though? I think we need to have a specific exception for this. Parser error? Is that like the convention in OCaml? Parser error, for example? Is that a good thing to do? So if there is a parser error, then it should be nothing. Then it's fine. But if it is... But if I actually did parse successfully... be this. But if I actually parse successfully, then I actually should panic here. You know, test fail. Test was expecting to not be to parse was supposed to fail, right? Something like that. And then I also want to print what was parsed, probably. But AST is optional. Can I say option print? Oh wait, I have option print. Yeah, it just prints none. How about this? None. Okay, so then I need to specify what's the parser error specifically, and over here when I fail, it should not be fail with. This should not be fail with. This should be erase. Let message be that in raise raise error message, like that. Okay, and then we specify what an error is. So we just exception error of string, right? Okay. Fail with, yeah, like this. Yeah, fail is basically the programmatic error, right? And then the user error is the error. Let me search for more fail withs. Yeah, like that maybe. Could not finish parsing. Message be this in raise error message. Well, you know what? Instead of fail with, we just have the error. How about that? How about we just have the function error? So error format is let message be oh format af printf, I guess, because I need to do something after printing, right? So I need to print into the formatter, which would be str formatter. So I'm printing into the str formatter, and then after it has been printed, I have get the formatter, and then I say format large string formatter, which is going to be my message, and then I raise error message, right? Is that how it's supposed to work? So the formatter is not really used here, yeah. I think that's yeah. So this like I don't do the main string. I just say error and like that. No. Okay, the test it looks like it succeeded, right? I might just want to have more errors instead of fail widths in the parser and maybe lexer too. I don't know. Not enough value supplies. Too many values. This is program like this should never be there. Duplicate rule. This one is actually the error. Yeah. Yeah. This is the parser error, and I guess this means that the parser. No, it's fine. I have just one file in the parser. How big is it? 340 lines. Yeah, I guess it's fine. So these are the only two, which is fine. I guess. All right. Yeah, so like basically if I make this thing that doesn't actually fail by removing this F, right? It will say that, yeah, there we go. So this was supposed to fail, but I actually parsed an if. All right, yeah, there we go. But this should fail. Okay, good. Parser error. Okay, what next? What next? I wanted to do something. Why did I do this? I want to do something else. Oh, right. I wanted to have the syntax rules to be defined not in OCaml, but in another place. And before doing that, actually, I think that this over here, like if I look at this, we have priority, and then we have greater than priority, greater than equal than priority. I'm actually wondering if there is a value in this. I mean, a value in... so we have the rule set, we have the rule, right? We have the rules. So the rules have the parts, and every part, if it's a value, then it can specify the priority filter. So like we say greater or equal the thing, but I feel like it will always it will basically say either greater than the priority of the rule, greater or equal than the priority of the rule, or any. So like I feel like this is not what I want. So I want a simpler version of the filter, which is filter kind, I guess, which is greater or equal, or any. So like just these three. And here you go. This is the other annoying part of OCaml. I hate this. I hate this. I mean, can I specify that this is a filter and not a filter kind? Okay, this fixes it actually. All right. Okay, not too bad then. Not too bad. So yeah, when I specify the rules, I just want to say that it's greater or equal, or any, basically. Yeah, and then I will do the filters. So the rules are going to contain in the parts in the bindings over here. How's OCaml treating me? It's getting better. It's getting better than in the beginning. I still hate it, but at the same time, I also still hate Rust. So I hate everything. So technically, if I hate everything, it also means that everything is good, right? It's just a me problem. So yeah, it's actually is good. I don't hate it too much. There are parts of Rust that I hate more than in OCaml. There are parts in OCaml that I hate more than in Rust. Why do you hate Rust? There is lots of reasons to hate Rust, but the biggest one is the compile times, I guess. Priority, yeah, so priority is not a filter, it's a filter kind. Yeah, that's why I'm going into a camel, specifically to make it compile faster. I've written enough in a camel to see how it compile times compare. No, I have not written enough, but that's what the internet says. It's supposed to compile very, very quickly. So hopefully that's true. Hopefully that is true. So if I add a rule to over here, then I should convert the priority to. I will basically say that priority filter is a rule priority make filter with this kind and with the rule priority, right? I think this is what I want. So what is the make filter? Make filter is a function that takes the kind, which is a filter kind, into filter. That's what I want. A filter kind, priority, and the filter, right? Yeah. Yeah. So it's a function kind priority into match kind with like this. Wait, did I not say the OCamling format stuff? Hold on. I was looking into that, and then break cases is top level. Break cases is top. That's what I want. So this will make this code look like that. That's what I want it to be, yes. This is good. What was my project again? Cast is this. So I'm right now rewriting. We only have the parser, and the parser is supposed to be extensible, which basically means that. So like, let me show you the thing, right? So we can have so 2 plus 2, for example, here, this is a quote operator, which is just constructing the AST, so I can debug it, right? So this is the binary operator where left-hand side is 2, right-hand side is 2, right? But we can have a custom syntax, which means something like this. Syntax custom. So this version requires specifying the associativity and priority. And then we specify, you know, like hello. I don't know, this is, and then this is value custom. This is value, you know, I don't know, we can do something stupid like this. Custom syntax, right? So this means that I have specified this and this and this and that to be like the keywords, and then value is like the inner value, you know? So I can try something like this. This is 2 plus 2, which is custom, you know? So like, let's see if this works. This doesn't work because we need a different priority, right? Probably. Okay, well, let's expect a value or closing bracket at 5. 1, 2, 3, 4, 5. Let me just try to do it simpler first. If I just do this is, yeah, see this has been parsed as a custom syntax node, basically, right? And then this is value, and then I say this is 2 plus 2. Is going to be parsed to a custom syntax node where value is the 2 plus 2, right? I'm wondering why does this not work, actually? Maybe because it's the bracket. So like this. Yeah, this cannot. Yeah, so I have successfully parsed this is, and then I expect an opening bracket, but it instead went to inside of the value, I suppose. Yeah, that's probably what happened. Yeah, that makes sense. Although this is probably looking like a bug, so maybe we will fix that. But yeah, I can basically specify custom syntax, and then it's going to be parsed like that into like AST, and then you can expand this. So this is like this is basically like converting it into a simpler language, like a Lisp, and then through the system, similar to the Lisp macros, you can like convert this to some other code that that can do so like you specify the meaning of the syntax separately using a macro. That's it. But yeah, for now we just want the we are just having the parser rewrite. So greater is greater priority. Let's just call this P. Greater or equal P, and any is any. There we go. So this should be priority filter. Go. Down. Can I have like OCaml FMT? OCaml FMT? OCaml format? Can I OCaml format the entire folder? Can I not? Something like cargo FMT? Root of the project is specified, only takes into account OCaml configurations. Maybe like go dot. I don't know. I mean, we can specify all of the files like maybe like star ml or something. You must specify exactly one input file. Oh, without in place or check. Yeah. What about we do if we do check, right? So yeah, parser pp says illegal character. Oh, and then this should not. Okay. I guess we need to source like that. There we go. This returns non-zero exit code, which means that the check-in actually failed, but it doesn't specify me what exactly is wrong. But I guess if I don't do check, but I say and in place, then it will format all the files. Yeah, see, now we have 8 changed files. All right. It would be nicer though if it could just format the entire Dune project. Maybe there's some like Dune FMT. Oh, there is Dune FMT. Okay. All right. I was just guessing, and I guessed correctly. All right. It looks like the renaming, by the way, works really wrong in OCaml, because I did not rename this field. I did not rename this field, but it renamed it over here. The rename works incorrectly because I had a variable which was called the same as a field, right? But this is still called priority, but like it changed it in the other places. Oh, actually it didn't. Wait, this is what? This is the rule. Yeah, rule still has the thing that's called priority and not P. This, yeah, the LSP can be better. Just say all P equal is, well, P is parts, right? That's what it is. It's not priority even, which is weird. Oh wait, maybe it didn't do it correctly because I didn't start my LSP support, right? The Dune build stuff, of course. Yeah, so like now when I specify the rules, I don't need to specify the priority over here because this is just a kind like that, which means that just easier. Which means that I don't need to have a let priority. I will instead say priority is equal to 0 here, so this let is unnecessary completely. Priority is 0. This is going to be changed. Priority is 1. Delete. Is 1. Delete. 1.5. Delete. 2. Delete. 1000. Delete. All right, just a small simplification. But the reason for this, yeah, I guess over here too. Priority is 10. Priority is 1. 1. Priority is 1. Okay, like this. Okay, it successfully builds. Can I test? Okay, tests work. Okay, so the reason for this simplification is because so I want to have like the syntax that defines the rule, right? So that I don't specify this in OCaml, I specify this actually in code, right? Similarly to how I did it over here, right? So syntax custom, this was having associativity, priority, and then the actual definition. So instead of this, instead of having the associativity, I mean, associativity is good, but it's this is more flexible if I do it like that, right? So for example, this over here should be written as a complex syntax with priority 10, right? Which is defined as name, name, and then opening bracket, closing bracket, and children, right? So opening bracket, closing bracket, and children inside here, right? And so for each of these parts, now I should be able to specify their priorities, their priority filter kinds, right? So specifically for this one, I want the name to be greater or equal, and I want the children to be any. So this maybe I do something like you know, yeah, I feel like colon greater and colon any. So there's like the three variants, right? Any, greater, or greater or equal. What would be like a good syntax for this? If I look at a language like another language that does this, which is Lean, or like other provers, what is their syntax? Not examples, tour, or language reference, notations and macros. So yeah, they also have the extensible parser, parsing. Notations. They call it notation, defining new syntax. Lean's uniform representation of syntax is very general and flexible. This means that extension to Lean's parser do not require extensions to the representation of the parsed syntax. Yeah, they also have the missing syntax for the parser errors. Actually, I should do that too. That makes sense for the language servers and stuff. Custom operators. Just show me the example. What is example? Yeah, so they have this infix, infix, infix. Right? But this is basically the like infix is basically the syntax sugar for the more general custom notation. Yeah, there you go. There you go. So they have a notation instead of syntax for it, right? Well, there is a name for it, which is ignore. And then the definition is ignore, which is a keyword with a space after it. Which I think is used for formatting. So I should think about that too, because I did not have the formatter. But this is how you specify how to format a custom syntax, right? And then you have the ignored argument and e argument. Oh yeah, so like yeah, it has two arguments. It ignores the first argument and returns the second argument. There you go. So the notation is ignore the first argument and the second argument, and then they said they have colon arg, precedence used for application arguments. So yeah, arg is the precedence here, right? So yeah. What does this mean though? Yeah. So like the precedence is arg, max, lead, or min, right? Or a number. So yeah, parser precedences. Most operator precedences consist of explicit numbers. The named precedence levels denote the outer edges of the range close to the minimum or maximum and are typically used by more involved syntax extensions. Precedence may also be denoted as sums of or differences of precedences, so you can calculate like that. Sure, you can do it in parentheses. The maximum precedence is used to parse terms that occur in a function position. Operators should typically not use this level because it can interfere with users' expectations. Argument precedence is one less than the maximum precedence. This level is useful for deciding syntax that should be treated as an argument to a function, such as fun or do. I'm wondering why they have this like that. Lead precedence is less than argument precedence and should be used for custom syntax that should not occur as function arguments, such as let. The minimum precedence can be used to ensure that an operator binds less tightly than all other operators, which is basically like over here I call it any, right? Okay. Yeah, you know what? I don't know what is this useful for, but maybe I will want to make it more general eventually. For now, I will just do my original plan, which is having so colon and then precedence basically is the idea, right? Colon and then precedence. Although this right now by the lecture is specified by is parsed by a single token. I could use colon. So colon any is easy. What about the greater? Maybe I just call greater. Or maybe it should be on the left side, but that would be weird. No. Name greater. So greater or equal are the options. And I think for greater or equal, I can just use the equal sign, technically. Would this be too weird? So equal, greater, or colon any. Is that weird? So let me have this simple syntax defined in the rules. Right? So I will have all of these in a file instead, and we will parse the file here. So we have basically complex 10 is equal to. Wait, why is this OCaml? It's not OCaml. This is plain text. How do I change the file type? Text. So complex 10 is name equal opening closing bracket with children which are any inside. Okay, something like this. So instead of 10 lines, we have just one line like that. And we have comma 1 which is so and then we have unnamed things too, which will be underscore. So underscore, which is equal comma, and then underscore, which is also equal, I guess. Or we can, so like if this means that it's technically a right associative, but I guess I can do this, which makes it left associative operator. Okay, and then we have a trailing comma is trailing comma 1 also is underscore comma. Maybe there should be a default, you know? Maybe there should be a default. So like the precedence filters here are either any, equal, or more. Maybe more should just be the default. Is that weird? And I want to do colon equal, you know? Colon more. I don't know. Maybe this should be like optional. Maybe like this is explicit, and then some of this should be default. Maybe. So for the trailing comma, it's the one that's greater or equal here, and then the trailing comma like that. And then we have named one, which is name is greater, and then an equal sign, and then value, which is another thing that's greater, like that. Okay, so instead of 50 lines, we just have 4 lines now. We just need to parse this, right? Yeah. So let's do that. So parser will have the way of parsing a rule, right? So rule, just parse a single rule. Rule parse is a function that takes well, I guess technically it should take a lexer, right? And then it's like just reading the thing from there. Lexer, and it returns the rule. Yeah, that makes sense. This function lexer. So name is the is get name of the of lexer pick, right? Where get name is match spend value, because this is a token spend, right? So I'm matching the value, if it's either a string token, which has value inside, or contents. Yeah, we have contents. Then I want contents. If it if it is identifier, I want that. And if it is anything else that I want to I want to throw error saying that I expected rule name but got and print lecture token print spend like this. So I have the name, right? And then I return the rule with this name. This has other fields potentially, right? I don't care about. Bound, yeah, this is Lexer T, I guess. Okay, so we have the name. After the name, we have the priority. So priority is get priori is actually, let's do this, Lexer token as float, Lexer peak, right? Also, since I peaked it, I need to actually consume it here. We actually do next then. Lexer next. There you go. Okay, so priority. I need to be able to convert tokens. And to be able to convert tokens into float, as float token into float, which is going to be a function. If I have this must be basically a number, right? This must be a number, raw. Then I say parse float. How do you parse how do you convert a string into a float in OCaml? ROM string. Of string. String raw. Of string throws raises a failure. Why does it not raise invalid argument here? This is weird, actually. I think it should. I think it should instead raise invalid argument. Similarly, if this is not a number, this should also say invalid argument. Like that. Can I have try with also be on separate lines in the OCaml format? Try. No. Maybe dash try. What's the option in OCaml format which controls the try with break cases and break indent and cases indent. Break cases controls whether each case in the width starts on a new line. Yes. Controls how far the indent. No. Like, it's basically if I had multiple cases here, they would all be on its own line, right? But I want this to be on its own line. Right. Like I want something like this, maybe. Like a normal try catch, like in your usual programming language. I mean, maybe sometimes I want it to be on a single line though. I don't know yet. Let's keep it. So I have as float, which is yeah, I can look over here. Unbound module parser, beautiful. Restart parser, unbound value token, lecture token. As float. What do you mean unbound? Lecture token is token, which has as float inside. Why is it unbound? Because Lexer MLI probably, yeah, because the token here is this signature. We need to have a value as float, which is token into float. Like that. All right. Then this priority is float. Yeah, so I need this. Yeah. So I will actually like try catch here, right? So priority is this, where let token be that, in that, in try to do that with invalid argument. With invalid argument be I instead say error. Expected rule priority got spend print token print token. Okay, as float token value here. All right, beautiful. So we have name, we have priority. The last part is to actually figure out the rules, right? So yeah, next I need to actually say that over here have something like token is Lexer next, and then I say token dot token raw token value is equal to an equal sign, right? Because I expect an equal sign, right? I'm parsing this thing. I expect an equal sign. So if it's not equal, then if it's not equal, then say error. Well, I mean, if this is not equal, well, I mean, that's all I need to do, right? Then I just error expected an equal, but got this thing. Okay, and after the equal, I need to collect the parts, right? I need to actually collect the parts. Yep. So parts, we need a recursive collect parts, right? So yeah, parts is collect parts. Like this. This is going to be a loop. So we take the token. Not next, we just pick here. And then it depends on the token here, right? So basically if raw, let me see, so is part is to have a function that should return an option. Or I guess not even not even a part, right? Yeah. So part is an optional part, right? Like this. And then after that, I basically say something like this: a match part. If it is some part, then I say we have part, and then collect the rest of the parts, right? And if it's none, then I just say that I return an empty list here. There you go. And yeah, also if it is actually some part, then before returning this, I need to say that Lexer skip, which actually should be called advance, probably. I'll rename later. Okay, so a part is one of the things, right? We first want to see if it's a keyword, right? So yeah, I guess I match token value here. And if it is a string where we have some contents, then this means that I want to, then this is a keyword with the contents of the string being the keyword. If it is an identifier, actually, you know what? Skip. This is actually weird. I think I will skip here instead. So I skip and I return the keyword. Okay, so I have an identifier. In any other case, let's just say none for now, right? That's only the things that I expect. Is the only things that I expect. So if we have the identifier, then I do skip. And I return none. Your vertical bar was missing. Okay. Vertical bar is missing here. My width is missing. So so we have this, and then I say something like so member, or not member, yes. So name is, if raw is equal to an underscore, then none, else it is some raw. Probably not raw though. Fact. Yeah, I want like the identifiers. I don't have like the actual names here. Do I want to do it right now though? Let's do it later. So we have that. We have the name, which is an optional string, right? So I return some value where we have the name. And then we also need to have the priority, which is a filter kind, right? So now we need to figure out the next token, right? So peak is Lexer peak. And then I'm going to match Lexer token raw peak. If it is colon, more than, then I say that we have a priority greater. If it is anything else, then I say so this is the default. What should be the default? Maybe I say that there is no default. But yeah, we basically have this. We have equal, which would be greater or equal, which is a little weird, but I think that makes sense for the syntax rule, maybe. Let's have no default for now. Expected value priority got spend print Alexa token print yeah, and then there is yes, like that. Yeah, I say that priority be this, right? And raw peak value. Yeah, there is this thing. There is also just a colon. In this case, I expect the any afterwards, right? So Lexer skip Lexer and then I say that if token raw Lexer peak, I guess Lexer just next here value no peak. So I just pick here again. So if the raw is not equal to any, then error expected any got that. And then I just return priority any, right? Yeah, maybe we will like have some other stuff later. How does this work, by the way? Hold on. How does the comparison work for the like comparison is just working for everything, right? You know, Camel? Is it structural comparison? Is that what's happening? Okay. I think this is probably it. I think this is probably it. I just need to parse these rules now. So in this simple syntax, I just say that the rule set is a rule set. Let's see. So I want to open a file. Can I open a file relative to the ML? Like similar to include a string in Rust. Is there something similar to include stir in OCaml? No, OCaml does not have a direct equivalent macro, but you can fake it with a preprocessor step. Is there an existing preprocessor step? Um, can you have a syntax extension, a preprocessor that actually reads it at compile time? Preprocessor magic with use or mod use only works in the top level. Option 3, use OCaml find plus ppx blob. ppx blob to embed the contents at compile time. Yeah, there you go. This is what we want. ppx blob. So ppx blob. ppx blob. I'm imagining something like this. So I pre-process. With ppx blob, right? Now this thing is not there, so it probably exists. It probably then exists over here, right? Yes, it does exist. Okay, ChatGPT didn't lie to me for once. So we have this, and we have the ppx blob is not found. Restart? No, I don't need to restart. I need to do this to reload here, and then restart the LSP support. There we go. Success. Okay, so now I can use the blobs here, right? So so we say, what's the syntax? Like that. Percent blob. Could not find a file. All right, so is this relative to this file, like rules? Where's the documentation of the ppx blob? ppx blob. Hello, Bowl City. This is a couple of ppx to include a binary blob from a file as a string. Wait, what? A binary as a string? Does that even make sense? Or is strings just binary things in OCaml? I guess they are, right? Dune, add preprocessed deps. File this to your library executable stanza. This will make sure that if the file is copied to the build directory, therefore visible to the ppx blob. Okay, so we need the preprocess deps here, right? Preprocessor deps is a file which is the rules, like that. And then we have the rules inside. This expression has type string. Yeah. So like this is a string, right? This is my rules, and then I want to parse them. So the rule set of list. Okay. Can I have a string lines? Why is there no lines? Okay, we can split on character, which is a /n, right? This is our lines. I feel like you know what? Let's actually have this like in the parser. Yeah. You know, like parser, the rule set. So just rule set. Parse lines of this blob, like this. Like this is not really the cast syntax here. The cast syntax will include the syntax here, I guess, and a semicolon in the end. This is just one rule per line. So yeah, this is parse lines, like that. So yeah, just like this. Okay. So rule set And then parse lines. So parse lines is a string into the rule set. Yeah, so this is going to be a string split on character /n. So yeah, it's a function. It's a function s into. So basically, yeah, we split the character on s, and then we like filter. And then we filter the lines which are not empty. I also don't want it to start with prefix, which is like a comment. Maybe I want to comment out things. So comment will start with a hashtag, for example. I don't want it to start with a comment. And string is white space, which means that it's completely empty, right? So these are ones I'm going to filter, and then I'm going to say list map using rule parse. So over here I have the function line, right? I guess I create a new lexer there for each line. Lexer is lexer initialize. This will like not report it correctly though, I feel like, yeah. If in case we have the errors. It's fine for now. I don't care. Let's initialize this. Initialize lexer default rules, and the source is contents is line, and file name is rule. I don't know. Let's have this. So rule parse lexer, I guess. So yeah, we have this, and then after we parse every rule, we just say of list, right? So we convert that list into the rule set in the end. Starts with this line. There we go. And then I need to specify what is white space. So is white space is string into boolean, which is function s into string for all character is white space. Just like that. Okay. And used type A. Type iter used. No, it is. It's fine. No warnings. Okay. Doing test. Okay. That was not very quick to compile, by the way. That was like almost a second, wasn't it? And I'm just starting. He was looking at my commits a few hours ago. No reader could read a token. Okay, this error needs to be improved. No reader would read a token. I want in the lexer to also have the error, I guess. Exception error. I want to have a function error format, like very similar to what I had in the parser a second ago, just like this. The constructor error, yeah, error of string. Okay. So over here, I don't want to do this. I want to do the error. No reader could read a token. Basically, it is it's going to say unexpected character %C, I'm assuming, at %A, right? So the character is reader peak. Is reader peak reader, like that. And then the thing is span dot print reader reader position, which is just position, right? I expected something token spend. Yeah. So like this should print not the token spend, just yeah, just this. There you go. That's how you do it. Okay, so unexpected character 1 at line 1 to 9. Okay, that makes sense because I don't have in the Lexer. So I have like the Lexer rules for reading a number. Yeah. We need to be able to read a number. Okay. Read number. Reader is what? So first of all, reader peak. So if character is alphanumeric, no, is digit. So it must be a digit. It must be a digit. Let star nothing be character is digit C, then some, else none. That's how I return early. And then I say reader read while. Read while. So character must be a digit, or character is a dot, which means that. Oh, but then it also means that I have seen a dot, right? Yeah. Okay, fine. I'm just going to match. Let's just have function here. If it's a dot, then we do true. If it's a C when it's a digit, true. Otherwise, it's a false, right? This is raw, and then I return some token number. Or read while this from the reader. Yeah. Reader into read while. Like this. I should use the pipes like this more often. This is basically like calling a method on the reader, right? Piping this function. That makes sense. Yeah, so like if it is a dot, then I'll like, because there must be only one dot, right? So scene dot is a reference to false. So I say that when dot scene dot, you know? Yeah. So then I say that scene dot is true, and then I return true like this, right? So I only allow the dot if I have not seen the dot yet. Okay, and this is going to be my numbers. Okay. Expected value priority got and a closing bracket at rule 138. Line 38. Oh, column 38. Is this the one? Column 38 to 41, which is basically this. So like this over here says that it expected value priority. But got that. Okay, there is something wrong here. Parse lines. I guess it's in the rule parsing, right? So I say, maybe I didn't skip something. So name is get name from the next thing. Okay. Priority is that. Then I want, then we see the equal sign. Yeah, then I see the equal sign. And then I collect the parts. I peek. Okay, I skip here. I skip here. Oh, because I peeked, but I didn't get it. Yeah. This. Yeah. Yeah. You know what? Let's actually match peak value with well, I mean, not even match. Yeah, never mind. Yeah, I'm just saying that I should say Lexer skip here because I read the I read the any. I need to like get over it now. Okay. Unreachable reached. Get name, comma. Is argument. At test 117 to 120. So we have a test that failed. And then I'm trying to get the name of a named thing. Yes. So are you saying that I specified the rule incorrectly? I have a name here, right? Yeah, I have a name. We had a name here, and we have a name here, yes. I think this is correct. So this is the bug fix. Hello, Veldak. Get name. So I have a comma. Unreachable reached. S. Unreachable string. The test itself. The test itself is this test. So in this test, I say that I parsed a comma. Wait. Get name, comma. Which test? This test. This test doesn't have any commas. Oh wait, this one has commas. Yeah, that's right. So this is the string that I'm trying to parse. So in this string, we have this is column 8. 8 plus 17 is going to be 25. Um, wait, hold on. Comma, opening bracket, underscore is arc. Ident. At this place. And then we have underscore is arc. Ident. A test. Wait, hold on. There is the same span specified twice. And then it is 7 to 20. It's actually 7 to 20. So let's see. 1, 2, 3, 4, 5, 6, 7. No, over here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So starting from here and ending at 20. 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, so it parsed this thing. Did I make the rule incorrectly? But let's say f is some arg, because this is indeed incorrect. Should probably be called unreachable, but yeah. Do I have the incorrect rules, or did my rules parse incorrectly? Let's see. Yeah, I have a comma with priority 1. So yeah, there should not be an equal parsed there because I have a greater, right? 2. Now we have index out of bounds. Beautiful. Now we have index out of bounds. Yeah, because in a comma I need to get the thing. Yeah, I did see that issue. It said underscore is equal. I feel like we have a bug though. Let me just do this. I also have the comments here. So that should lead to the same, yeah, out of bounds. Yeah, so the problem is that this is supposed to be an unnamed field, but it was actually a named one. And why is that? Let me try to tokenize this and see what's wrong. So source, parser, simple syntax rules, right? Unexpected. Oh yeah, it was, yeah, okay. You know what? It only is trying to do the KS files right now. Let's remove that restriction. Path. Let's just say path to some file path. Tokenize. All right. Yeah. So we have underscore. Yeah, underscore is properly an identifier. All right. So the the lexer is fine, I think. The lexer, I think, is fine. Which means that it's the rule. That is incorrect. So rule parse over here. I say name is get name, because if it's an identifier raw, then it should be raw. Hello Raymarch. How are you doing? I have a question for you, Raymarch, since you like thinking about like namings and stuff too, right? A lot. So we have in cast the feature which is called a tuple right now, right? It's called a tuple, which is 1, 2, 3, right? This is use default number type based on dot. Hold on. Maybe I will change this to comp time. So this gives me a tuple with 1, 2, 3s, right? Call it a non-struct to be different. No, because it's not a non-struct, because the tuple can have both named and unnamed fields at the same time, right? So we have A is 1, B is 2, right? This is a struct with named fields. And then we can have a mix. -1, -2, 0, right? So this is a struct which has 3 unnamed fields and 2 named fields. What should I call it? Named fields in a tuple, is it Christmas already? Yeah, like I'm just calling it a tuple. And I was wondering if that's like the good name. But I don't know the alternatives. Like alternatives would be like records, struct, and do names matter to time checking? No, they don't. But we still should name things in code appropriately, right? Oh, you mean like the names of the fields? Yeah, the names of the fields, they matter, yes. Yeah, this is like .0. I think I even have the syntax where I can say .0 is equal to that. No, I don't. I think I mean I can say that if this is like a tuple, right? Then I can say dbg tuple.0, and this is the first thing, which is the -1, right? I don't have the initialization with that, which I should. But yeah, names are required too much. And also, by the way, I was looking at another language. Is .a1 and .a2 the same type? It depends. It depends, because the type of this is actually like it can be a named type. So for example, I can say this const foo is type, where a is int 32, for example, right? I can do this, and then I say that let const, I don't know, let's call it A and let's call it B, right? So these are the two separate types, const A and B. They look the same, and I can say that A is of type A, where A is 1, right? And then I say B is B, which is A is 1, right? Does that work? Macro then. Line 5, column 19. This is the old version of cast. All right, which means that I probably need to do this. It's not the latest version of the playground, unfortunately. Type. Like that, yeah. So then I can say that A is equal to B, for example, right? dbg. dbg A is equal to B. True. Okay, actually, this is the old version, I guess, like this is not supposed to work, because these are different types. So like in Rust, for named structs, you need to specify the name here, but I don't. So like the actual type of this thing is inferred, right? Through the type annotation or somehow else. So I don't need to specify that this is a named struct specifically, right? So this right now defaults to anonymous, but it can be a named one, which like syntactically looks the same. They do the same thing in Zig. Although in Zig they remove the anonymous ones, which we'll see if I will do the same. So does equality break as soon as one field is named? What do you mean it breaks? Well, I mean, if I say that over here we have the B, for example, it should say that unreachable executed. All right, beautiful. It's, I don't know. We have the we have a panic. Yeah, name not present in another. This is not supposed to be a panic, but an error. But yeah, type checking didn't succeed here. YouTube lane that it would work. No, it will not work. I mean, this is a different type. It is a named one. Yeah, like this cannot be like basically A is one, and just one, right? This is just a tuple with unnamed field, and this one with named. This is different types, right? 1 is equal 1, right? But yeah, because this is named. But at the same time, maybe you want that sometimes to be the same type, right? So I was trying to get to it. I was reading a little bit about the Mojo and how they do it, and I think I like. I mean they don't do it for like the types, but they have it for the function arguments, similarly to Python, right? So you know how in Python, you can do. No, dot a is 1 is equal to dot a1. No, it is equal, but like sometimes it can be a different type, you know. It kind of depends. Yeah, and like not always. Like I mean they are equal if it type checks, but if it doesn't type check, then they're not equal. But yeah, you know how in Python you can have a function f which has like a. And then you'd have a slash, and then you have a B, and then you have a star, and then you have a C, you know? And then you like print ABC, right? So if I call F, this will say that we're missing 2 required positional arguments, A and B, right? So I have a function with 1 and 2. Right, and then I also need 1 keyword only position, right? So this is C is equal to 3, right? So I must call this function with these 2 being unnamed fields and this one being named field. But at the same time, the second one can be both. So B can be specified or can be not specified, right? So in between the slash and star, you can have fields which are both named and unnamed, right? So I don't have this functionality, which is like maybe what you were asking about, right? But I think that maybe we want. And then I was looking at Mojo, and Mojo has another thing. Mojo, it calls it infer-only arguments. It calls it infer-only arguments, basically. And I think I want that too. Infer only arguments before a double slash. Have I lost your Mojo? Yeah, so basically, like think about it something like this. When you have in Rust a function, right? Like when you have a function foo, and you have a generic argument t, right? And then you have x of type t, and then you have y of type impl foo, which is like a trait, right? You know, if you do this, then technically foo is a generic function in which actually has 2 generic arguments, but this argument is like infer only. You cannot specify it using the turbofish. You can only infer it, right? Because it's an impl foo, you know. You call them non-lexical type parameters. Yeah, so like since in cast I make the generic to be just functions, right? So technically foo is a function which takes a t of which is like a type, right? And it returns a new function, right? So it returns like the actual implementation which takes x of type t, you know? So over here we have another like hidden argument which is another type, right, which implements foo or something, right? But this argument, we want it to be like implicit argument. We want it to be always inferred. So like even Mojo, they do it with a double slash separator or something, you know? So like we need some form of a separator here to split the infer only arguments to make it like make it work, because I feel like we want it sometimes. Does it mean you can also infer values? Yeah, I do. I can infer values, yes. I mean, Rust can also infer values. It just calls it const generics feature. So in Rust, you just by default have the type here. But I just infer the type of t, which is the type, usually. Rust const generics are meh. Yeah, they are meh, but the idea is the same. Anyway, so that was my question about first, what should I call the tuples? And is tuple a good name, or should I call it something else? And then I wanted to talk about this a little bit, because I think it's nice. So like we have basically we need to have a type which has 4 types of fields: the infer only fields, the positional only fields, the positional or keyword fields, and keyword only fields. So back to my question: does one underscore have the same mechanism? The same mechanism as what? I mean, yes, it is. It does have the same mechanism as like whatever mechanism. Can one be not? Yeah, it can be. Like like because an unnamed tuple is like so Rust calls Rust has the distinction between structs and tuple structs, right? So in this case, 1 comma is the tuple struct. It's just like that. The tuple struct can be anonymous or named, and if one of them is named, then the names must be the same, basically, right? I mean, in general, like the name must be the same, and name may be absent, right? So name is an optional string, like not exactly string, but the names must match, right? So that's why they are not always equal. Yeah. Like they cannot be equal. You can do this with explicit like type signatures, I guess. Can all these be just be a struct where all the names are option? No. How do you like I mean it's almost what it is. Yeah. Can we get there? Hold on, I'm not sure what you're asking though. Can we get where? I need to like clone the cast again. Let's clone temp, and then let's clone cast lang cast, which actually like is the Rust version. So that like I can show the what previously worked. 1 second. At push up redeem Veldec. Nah, too lazy, too lazy. Like instead of having 4 specific struct types, have one flexible struct type with simple rules. That's what I have. Yes, I don't have 4 specific struct types. I have a single thing, which I call a tuple. Are sometimes going to have the same features unnamed and named? Yes. I think it was already done like that. So yeah. Like you can see this. Like so, like I am in the REPL right now. So option is std option. So this one is named, right? And then I can say just variant none. So like, what's the type of some 1 to 3, right? What's the type of this? The type is not necessarily option. The type is not inferred here, right? I guess that's a separate feature. But you can say that another option. I mean, for these I only have the ability to do that. So some int or none. So another option is still. I mean, yeah, that makes sense. Yeah, I guess like I don't have a way to specify the anonymous type right now. Yeah, this could be improved. But yeah, the idea is that yes, we should be able to do that. Can you define a nested type like this, similar to a big pattern? Yes. Although you can, like, I don't have like the union types, right? I32 or U32. Like you need to have names to your variants, right? Like we have choice types of the enums, the ADTs, not just union types. So it's not the same. I mean, maybe I will have the union types too. We'll see, but I don't think I wasn't planning for them, at least. What do you mean it's not the same? In some types versus product types. Oh, you mean like yeah. The issue with union types is that I mean, the union type can exist, I guess, in the interpreter, but it cannot be existing in the compiled code. Like, how do you do a union? I mean, you can have a union in C, right? But you cannot. Well, I guess like the union doesn't allow you to do the pattern matching, basically, right? That's what it is. The union, like, you need to assert, basically, if you have a value of a type union, and you want to get a concrete variant, then you need to somehow assert that it is of this variant, which is like an unsafe operation, basically, somehow. Or some other way of proving that it's the correct variant. For example, checking the type, which is only actually possible in the interpreter, but not in the native code. A or B is B or A. I need to make sure that in congen both types know which variant you actually have. I was wondering if this could be the sum operator and comma the product operator. That is actually yes. There is a paper about this, in fact, which I think is understandable, unlike a lot of the other papers. I think I linked to it. Hold on, let me see. Incast here. This one. So it's called first class labels for extensible rows, right? And then so yeah, basically so basically you have this type, which is a row, right? Which is like a tuple, basically, which is why by the way, maybe I should change the name from tuple to a row, right? Yeah, but basically the idea is that you have some operation you have some operation like this, which converts like make sum type is is basically a thing which gets a row and returns a new type, you know? Row is nice since it's short. Yeah, maybe a row is good. So like a row is like it's like some row type, right? So yeah. I mean, this specifically is a row of types, right? Because what are a row where every field is typed? I don't know, somehow, right? Row type. I mean, maybe just row. Yeah. So basically, you in order to make the sum type, you just say make sum type, where you know, like A is int 32 and B is int 64, and then if we support for the rows the unnamed fields, then that will make it a union, I guess. If you only have the named fields, then it makes it a tagged union. And I don't know what it would mean like for the mixed ones, you know, if you have string or this like and then as you can see, it's not that the comma is the product and the vertical bar is a thing. You can just convert the product into a sum like this. But maybe, wait, hold on, maybe they actually did it in this paper with a vertical bar, which was the actual syntax for the variance. Yeah, maybe it was. Maybe it actually was. Yeah, and then they have the separate syntax. So you define the records here with the curly brackets, and the sum types with this syntax, and then you have the vertical bars. Yeah. Yeah, like you can do it both ways. And then you can also, like, this paper is talking specifically about treating the labels as first class things. So you can have the field, the name of the field as a value, basically, with a bunch of things that you can do with it. Just have the argument list of types and then functions that do things with them. It's like either, where this is basically std variant. Yeah, I guess so. You can make some function like std variant, which works like that. Yeah. Anyway, let's go back to being productive. But you like the name of the row? So a row would be, so we call it row because it's basically like a sequence of fields, right? It doesn't necessarily having each field being as the same type, like in a list, right? And then some of the didn't know you were building C++. I was saying that my language is going to be bloated, so in a way, yes. Do you have the problem with that in C++? The only problem is that it's not, is like when it's checked, when it's type checked, right? Or do you actually have, is there a feature in C++ that you would want to remove from C++? Tuple, keyword argument, row, stuff like that. Keyword KW args is for keyword arguments. But I mean, so we use it not only for the arguments, we store it also as a value. So I don't think args should be it. Like we basically use the tuples or rows to like mimic, to have the arguments in functions. Otherwise, all the functions have a single argument, right? But it's not only for that. But will arguments be a row then? Yes, arguments are a row. Yeah. Yeah, maybe I like the name row actually. Maybe I will rename it. Anyway, what was I doing? The template syntax graphic. You mean like you would remove the template syntax from C++ or just change it? That's just like Like the templates should still exist in C++, right? It's not a feature that you want to remove the templates, right? You just want to change it. Yeah, changing things, sure. Making the syntax more obvious, easier to parse in a bunch of places, sure. But it's not going to remove the bloat though, right? Which is what a lot of people are criticizing C++ for. I just don't think that the bloat is the C++'s problem. It actually doesn't have enough bloat, you know? It doesn't have the borrow checker, for example. Is a call type an array? What's call? What's a call type? Wait, where's the call type? Oh, if we have a row, then we need to have a call. You have rows, so you must have a column. Wait, well, I mean, rows are used not like as we see here in the programming language theories, and then they're also used in databases. So in a database, a row is basically like a tuple 2, right? With like a structure with named fields. And then if we think about the database, then the column is just a field, right? It's not necessarily a repetition, right? So a row has columns. Well, I mean, it depends, right? You have columns in a table, and then you have a column in a row, right? If it is, yeah, if it's like, yeah, which actually like also you mean cell? Do they actually call it cell though? Like when you, so you extract the row from the database, and then you want to get a specific. I was pretty sure it was called like column there still. Let's just say like Java, or like, I don't know, let's use Rust, fine. Like Postgres. Tokyo Postgres, for example, right? So we have the column. We have a row stream, which has a row. Row has columns, right? It doesn't have cells. It has columns. This, I mean, this is information about the columns, right? So column is just like the information there, and then we can get. It's called row index, and row index is either a string or usize, right? So yeah, you can basically get it by name or by index. Yeah, by the column name, right? So like you don't call it cell here still. Also refuse any naming coming from Postgres. Okay, what is the better choice to like, what is the better thing to follow? All right, I need to improve the things that I was doing, which was what? I already forgot. Thank you for derailing me, Raymarch. I have a test that doesn't work, right? Over here, index out of bounds. Index out of bounds when I'm trying, so I'm trying to get unnamed here. Yeah. Because I have in the collect children here, because it is actually a named one. Okay, yeah, that makes sense. That makes sense. Postgres is great. My experience with Postgres was okay. I didn't do like too much stuff. I don't usually work a lot with the database, I guess. What does it do good? Let's call them tuples. Actually, rows is also fine. But don't change it at this point. I mean, since I'm rewriting from scratch, that's why I'm actually thinking of changing it right now, before I like proceed with the rewrite even further. I think at this point we can change it. I mean, I think this is the time to change basically every choice that I'm having. So like I'm changing the way syntax is done, right? For example, SQL syntax or Postgres syntax. Oh, right. There's like different languages there. I mean, in a Postgres, you can write the thing in any language, right? Can you not like Postgres Python? Like you can have programming language Python inside the Postgres, right? They have PL Python, Python procedural language, as one of the options. You don't need to use SQL. You have you can use the Perl, right? Agreed on the language, though nowadays you can just program it however you want. I don't think I actually tried the actual like it's like programming language Postgres something completely like there's the SQL language, which is almost normal SQL, no? Like almost the same as in like the other databases. Is there like a yeah programming language PGSQL, right? Is this one the one that you don't like? Mm -hmm. PLSQL is inspired by Ada. Rows does make sense to me, but in Postgres, SQL rows don't named and unnamed fields point to the same values. Yes, which is like you just rejoined, Nigel, right? I was just talking about this thing where we should have the things. So we should have positional only fields. We should have positional or keyword fields. So like so if you want to mimic the SQL rows, so SQL has positional or keyword parameters where you can get the field either by the index or by the keyword, right? But sometimes we want the keyword onlys, and sometimes we want to be the positional onlys, and sometimes we also want the infer onlys too. We need to have 4 types. We don't have to look at everything that I don't like. We'll be derailing until tomorrow. No, it's good. I want to like I want to come up. I mean, I guess it doesn't really like matter much because you don't really use the word tuple or row when you are actually like programming in cast, right? There is no keyword tuple or no keyword row. It's just like the internal naming, so it doesn't really matter. The semantics though matters, I guess. Sometimes you want to get them in random order. Wasn't there also a thing about foo versus foo, one being a dense? Yeah. Yeah. No, it's not in all of SQL because I think in like in MySQL or in MariaDB at least you do the backticks to escape an identifier. But in Postgres you do the single quotes, I'm pretty sure, yeah. And then strings are double quoted. Yeah, this is just escaping the identifier syntax. Sure, yeah, I guess I don't really like that, the fact that it looks like strings, but it's only because you are used to strings, to like single quoted things being like strings or characters. Oh wait, is it the other way around? The single quotes are string and the double quotes are column table? I thought it was the other way around. Yeah, MySQL use backticks, yes. Being unable to tell you where the syntax error were. This is the thing that I need to fix myself here a little bit. All right, anyway. Let me fix. So we have that stuff. You know what? So yeah, if tuple if children unnamed, array length of children unnamed is not equal to 2, then or tuple string map or not, string map is empty, children named, which I probably should not have this as a public field, in fact. But yeah, let me just do here error. Parser error. Send a children. Percent a ast print ast. Comma is incorrect structure. Something like that is what I want. Exception parser error. You know what? Can I wait, hold on. Do we have in OCaml the hierarchy of errors? We don't, right? So like, because over here in my tests I have a try catch failures like this, right? And now I have the different one, so I need to have parser.error as a separate thing, right? And to explicitly have them all. I cannot have like a common error type, like like all exceptions. I guess that would make sense, maybe. All right. So yeah, comma is incorrect structure. Look at this. So we have underscore is named. Yes. Yeah, so this says underscore, which is incorrect. So this is a field with name underscore, which was never supposed to happen. This was never supposed to happen. So this is the rule parse. Get name. Wait, no, get name is correct. Yeah, hold on. It's this one. Name. It's the part is name, which is string option. So the raw is underscore. Oh, maybe it's wait, is it because of the double equal? What's the double equal again? This is physical equality. So like the strings, they are not necessarily physically equal, right? Can I disable the double equal in OCaml? Can I disable it? There you go. Now the test actually passes. You had a problem with that today? Yeah, it's like because I'm used to writing a double equal, I want it to be like a named like instead of having double equal, I want to say something like is same identity raw and like this, you know. I want to be very explicit because I don't know, because like most often I don't want that, right? Okay, the test actually passes. So there you go. That's what I did. We are actually parsing this as the set of rules, right? And then we parse. Okay, and then if I say the priority here, though, this is going to be incorrect. I need to figure this one too. Unreachable reached. Get name, comma. Named. Name is this. Name is, so f is sum. Unreachable. Get name. This one. So I'm trying to get name of this. Is unreachable my main function? Yeah, it is. It just failed with. Although I might want to actually do something like this instead, so it's like taking the formatter. You know what? Let me do it right now. Yeah, you know what? Let me do it right now. It's like very similar to... Like, can I do this like easier? Maybe like it's similar to this. So unreachable, rusty camel, yeah. Unreachable format. So this is just instead of raising the error message, we just say fail with message. You know. Yeah. So we don't say unreachable make string. We just say unreachable, and then I can have some format here, right? There you go. Yeah, I need to though. Yeah, before formatting. Before formatting, say s mat as printf unreachable reached, right? Like this. No, it's not sprintf. I need fprintf format stir formatter. There we go. So now we have unreachable reached and like um in a test error and line is what I want, because there was no line break. Yeah, there we go. Unreachable reached. Actually, I should just say fail with test so that it's a shorter one. That makes more sense to me here, I guess, because I already write it to the standard error. Okay, so I'm trying to get name of this, and this obviously is not a name. So I have a bug. But wait. Can I print the stack trace of this though? That's what I want, right? Because this way I don't have the stack trace. Print x. Can I print backtrace? There's a print backtrace. Record backtrace. Register printer to string. Get backtrace. Backtrace slots. Print backtrace. Get raw backtrace. Convert raw backtrace. Raise with backtrace. I guess it's like print backtrace. std error. Maybe like, is it going to print it? Yeah, it prints it. Okay, nice. So like, because I do it in the catch, and I don't care about that. I prefer using std error, not std out. But yeah. So this way we actually do things. Yeah. Maybe instead of fail with, it should just be exit. Exit 1. Am I liking OCaml more this time? Well, I'm more used to it, but I don't know. I mean, I can see how I can get used to it. Still, a lot of the parts that were annoying, they are still annoying. some parts of the type inference, some parts of the explicitness, so like the lack of traits, I guess. The lack of traits and some parts of the inference are the worst. And the lack of some syntactic sugar, like if let or like the similar things. But I guess the syntax sugar can technically be changed with like either the PPX rewrite, so maybe I can have my custom syntax in OCaml with a custom PPX, which I will write, maybe. We'll see about that. Or like I didn't use like the let stars before. Like I think this code makes the code a little bit more readable. I just don't like the fact that like it's a let star instead of a let c be like this question mark, because I think this makes more sense, especially if I have multiple ways where this can return none. Then I need to have like multiple lets, where in Rust we can just have multiple question marks as a single expression, right? So I mean, technically we can just like mimic that with like exceptions and returning with exceptions, right? But yeah. We'll see. There, like I kind of like a little bit like the fact that I can hack around, but I can also see how it will lead to bugs. You have not written a single trait in 1,000 lines of OCaml. Why is let star there? It's a different one. It's a different operator. It's similar to a let star, the let divide, but it's the one that is returning a unit instead of returning an option. You have not written a single trait. Well, I mean, have you not used something like map make, right? Have you not used something like this, map make string? So in order to have a string map, you need to make a map, right? This over here is a functor which takes the order type. This is basically a trait, right? Have you not written this yourself? I will write that because I will need to do that for like inference or some other parts. I mean, yeah, I guess I can see how it's only just functions because I didn't make like a trait for printing, for example, right? It's just like standalone functions. Yeah, maybe. Is that a hash set? No, this is the ordered map. The normal map in OCaml is the ordered one. Okay, you know what I need to do? Just parser. So this code, I need to try and parse this, right? Which I am doing over here, syntax parse, right? My process. Yeah. How about I do this? Let AST be that, and then I map it like this. And before that, I also say that I will match it. And if it's sum, then I want to. Well, I guess I do just option print AST print AST. Log debug. Yeah, I also added the log module, by the way. This is not in the standard library. So I can do this, and I can disable certain levels easily. parsed. Okay, so this is what I have parsed, right? I have a complex. Yeah. Also, I was looking at how to have the 3D printing. There's like these boxes in the 3D printing stuff. I need to do that when printing properly. Complex. Okay, so we have apply. I'm trying to parse this code over here. This code over here. So we have apply, where the children is named. Name is comma. Yeah, so okay, so this is actually parsed in incorrectly. Yeah, that makes sense. Name is comma. F is sum. And arg. So yeah, this it's parsed like this. It's parsed like this. This is equal to scope. I think that's what happened here. So is it just these rules are incorrect, or do I have a bug? Because if I have a named, which is name, which should be more with the more priority, right? Which comma does not have the priority, which is more. So yeah, it is a bug, right? What's the difference between a map and a hash table? The map is ordered, the hash table is based on a hash. Also, map is immutable, and hash table is a mutable data structure. Okay, I'm pretty sure this is a bug. How do I debug this though? How do I debug? Let's say that the max level should be trace. And we will see all of the things. Maybe I can have some simpler one though. Can I have simple syntax? Simple syntax parse, and I will ignore it. So the source is going to be A is B, comma C is D, right? This should be parsed as yeah, and then I have like a function like this. What I'm interested in. Yeah, so we have the same problem. What if I have this? This also breaks, all right? So the problem is that we parsed as apply, where children is a named, where name is a comma, right? So, wait, what? Wait, no. Exit 0. Yeah, this actually works properly, but CSD is not working properly. Okay. Yeah, because it's parsing this as a full thing before the equal for some reason. New syntax format. It's not new. It's just like, well, I mean, it is new, I guess, but it is for more precise specifying the syntax. I don't have the associativity. So you control the associativity by having over here either the colon equal or the colon more than. So equal will allow you to have the syntax with the same priority as the current rule, and the more is only allowing the syntax rules with the higher priority. which is why, like, over here, for example, since name should have more priority than the current syntax rule, which has the priority of 1, it means that this should not match a comma, but it actually matched a comma. That's the bug that is happening here. Did you know GitHub has so many unnecessary ways of viewing image diffs? How do I change the way of viewing image diff? What do you mean different ways? Below? Where? Here? To up? Swipe? Oh, swipe. This actually... Wait, hold on. This is actually... This is actually good. Onion skin. This is actually good. Hold on. I like that. I didn't know that this was a feature. Yeah, I didn't know. Huh? I have the kid playing around. He wants to play with cast 2, I guess. Alright. I need to fix the bug. Because it's been too long since I have done anything useful. Next iteration, cast Lego. Alright, so I parsed it incorrectly. Why did I parse that incorrect? So I parsed this, children is named. Where name is a comma, okay. Like, because it was literally working before, right? The simple syntax, this is my change log, right? So previously I had these set of rules. So comma had the priority 1, greater or equal, greater or equal. Oh wait, maybe this is the problem. Because I had greater or equal, but now I don't have greater or equal, right? This is the change that actually leads to the bug. Yes. Okay, that's the difference. Okay. I was wondering why it was working before and not anymore, because I changed this. Okay. Okay, but it doesn't mean that... It doesn't mean... Yeah. Oh, wait, I know. I know why. Okay, so what happens is... What happens is we parse this part, and then I'm trying to extend it, right? But I should only try to, like, because this corresponds to a to a thing. It should not try to extend with what? Yeah. I'm actually wondering if my previous parser was also wrong then. Can I try the previous parser? Let's try the previous parser. What? REPL. So if I have I mean it's definitely like if I say A is B colon C is D, right? This is assigning, where assignee is assign. Wait, it actually is a bug. Okay, it actually has a bug too, right? So it's saying that I'm trying to... Oh wait, no. It's because the assignment has the different priority. Never mind. The syntax here is different. But yeah, and this is a tuple with field A and field B. No, this is correct. Maybe I have different syntax rules though, or maybe I have a bug. But basically what's happening, we have the parser. I understand where the bug is at least. So the way we're doing the parse, right, is I'm trying to parse one, and then I'm trying to extend it. And then I'm trying to extend it in a loop, right? But if I have, when I try to extend, this is the ASD, which corresponds to a rule with a certain priority. Which let's see, I'm reading one already part, like this is literally the same keyword. Oh, it's because I have the continuation keywords, probably, right? Which actually fixes the bug. I think the bug is still in the even in the old implementation, in fact. But the continuation keywords like is a feature that I didn't implement yet, which like because I don't have it, we have also another bug, I guess. But yeah, I think the old one also had a bug. Should I go back to OCaml? You didn't like it back then? I don't like anything. Everything is bad. Everything is bad. Especially my coding skills. I'm making bugs. Let me try to fix this one. Like just can I like prove that I still have the bug in the old implementation though? Except cast is good. Yeah, well, cast is bad right now because it's not implemented. Eventually, of course, it's like the perfect language. But will we ever get there? I don't know. What would be an example? I don't know. Maybe I shouldn't focus on the trying to break the old implementation, just fix this one. But yeah, basically, if I parsed an AST and I use it as a value to initialize, and try to grow it, I need to know. Like, yeah, because I go from the yeah, so I'm trying to like go over here, right? But I cannot necessarily go there. I cannot necessarily go here because this node has the filter, right? Yeah. Over here and check. So we have node priority, no, value filter. We have the value filter here. Cast is good because no functionality. With functionality, we get bugs. So we have the value filter, and we need to actually like check that the filter is correct. Because I have the value, and this value was produced with some with a rule of some priority. Potentially, but not always. Sometimes it's a simple value, in fact. This is actually interesting. So when I start to parse one, this is not just AST, but this is AST plus an optional priority, or at least like a rule that was used to parse this AST, which we kind of have, but not exactly. We have the name of the rule potentially. We have the name of the rule. Well, I mean, if I have the name of the rule, then I can get it. Yeah. I guess. So, start. So my start value is potentially having a priority, which is going to be this is an AST, right? So I'm going to match start with start dot kind destruct. If it's a simple one, then we have none, and if it's a complex, where I have the name of the rule, right? This is where I need to figure out the rule that was corresponding to this one, right? Which is a rule set. So I need to store the rules in the rule set, right? Find rule with this name in the rule set, right? And then I want to say some rule priority. And then I say that so we have the priority, right? So should like filtered, I guess. I don't know. I don't know what to call this thing, but we're going to match start priority with. So none should just always be possible, but some priority then should say priority say something. Where is the priority? Oh, because it's rule dot priority. Make filter, stricter filter. Wait, how do I check? How do I check the priorities? Try to follow with a value. Next, value filter. Oh, I'm just parsing using that. Yeah. Wait, but I have the filter, which is being used over here. Um. Yeah, because this one is about the range. Okay, let's just have this rule priority check filter with range filter. And then I will also have the rule priority check filter priority filter. And then I say that if filtered, then I go node, but otherwise I just return no progress because I cannot do anything. So check a filter with range and filter. Range filter is match is this, right? So filter in this case is filter. And range is range inclusive of priorities. Okay, and then we have the also the function check filter with priority and filter. Then if I have greater x, then we just use the okay. And then I need to have, so this is the rule, right? So the find rule in the rule set should be so find rule is name of the rule set, and it gives me the rule, right? Function name rule set into string map dot find name in the rule set rules. I guess I will just store it in a map. So I need a string map to is map make string, and then rule set should have, so like I already stored the keywords, but I also should store just all the rules, which is string map of rules, right? Based on its name. So we start with rules being string map empty, and when I add a rule, the first thing that I will do, well, I mean, not the first thing, right? Over here, we'll say that the rules is string map. Hello, can I have autocompletion, please? Add rule name rule to the rule set rules, like this. That should do it, I think. Wait, what was I doing even? I was trying to fix it. Yes. So I still parsed it incorrectly. Is that right? Oh. Yes. This doesn't even fix it. Hold on. This doesn't even fix it. Sometimes when you use foo at, you get foo is a constructor expecting n arguments, but given 0 arguments. Don't remember having that exact error. Okay. I mean, okay. I mean, apparently, so I can fix it with continuation keywords, but I think it will still be a bug. So continuations is basically, so I'm like parsing a single node, and then inside of this I'm parsing another value, right? And then I see a keyword, but like what should it do? Should I start a new thing, or should I continue parsing something that I already started parsing, right? So continuations are about that. If I have if I can continue some partially parsed node up the stack with the keyword that I see right now, then I should not start parsing a new thing. That's why it fixes it. But I feel like it's not exactly like I feel like I still have a bug. I just don't know how to reproduce it if I will add the continuations. So I have it right now because I don't have them. But they don't fix everything, right? Because I potentially can parse something, and I cannot Well, I mean, I guess maybe it actually is fixing it. I don't know. I can't come up with an example. We will try to have more tests maybe this time. Maybe someone else will add the tests for me. I just I think I like made making the tests relatively simple, so we can just try to break. Okay, so then I just do the continuations. So it means that when I'm parsing the one, I should have another argument, which is the you know, continuations. Is continuation like an existing type? Yeah. Continuation keywords. You know? Let's have it actually a named argument. Continuation keywords. Which is basically a string set. T, right? What am I creating? I'm making a programming language and I'm making the parser for it. Rewriting technically. So I'm not making it. I already made this before, but I'm rewriting it in OCaml. It was written in Rust. We have a very generic parser, which can be extended at while parsing. It's an extensible parser. Yeah, I can show you how it worked before, right? So we have like 2 plus 2, right? It's parsing 2 plus 2 into a structure like this. So it has the name of the thing and then the arguments, the left hand side, right hand side, right? Like it's I should come up with a name for this too, right? Like it's almost a Lisp, but with named like things and the function being outside of the parentheses, kind of. But it's basically a Lisp that I'm converting it into when parsing. And then we have the way to extend the syntax by introducing a custom syntax like this. You introduce a ternary operator using this syntax, and then once you have introduced it, you can use the ternary operator later. And it's working with macros, just like in a Lisp. So continuation keyword string set t. Yeah, so we have continuation keywords. That's a big word. But yeah, basically I have the so I have the when I'm trying to follow up, when I'm trying to follow with a keyword, when I'm trying to follow with a keyword over here, and then this is a keyword, I should not try that if the raw token, I mean, if the keyword is the continuation keyword, right? Let me call this a keyword. So let this is match. So I'm trying to string set find string set contains, right? If it contains a keyword, if continuation keyword contains keyword, then none, else some. I wonder if there's like an easier way. Maybe, I mean, I can have another let which tries to have a boolean on the right side. Yeah. Yeah. This basically means like if since I have none here, this will stop and return none over here. Yeah. Lisp or Sexp. Well, I mean sexp, right? But like it's not a sexp, because once again it's not just a list, right? We have lists with names, kind of, and the elements of the list potentially also have names, right? That's the difference, because it makes it more readable, the output. In I think when I see like over here, right? I have a name. Is this right? It's not just like the first argument of the named is a name. We could have that convention, of course, but it's easier to actually see what is the meaning of the first field in a list, right? This is why I'm giving it names. Okay, and then the continuation keywords need to be when I'm parsing the inner value over here, the the inner value over here is being parsed. I need to tell it what are my continuation keywords, right? What can I continue with while parsing this value? Like, we are assuming that this is going to be parsed, right? So the continuation is going to be the so parse also should have before the filter the continuation keywords, which is string set. Right? So when I parse one, I parse with continuation keywords. What's the syntax? String set t, right? It's the syntax problem. Yeah, so when we start parsing on the outside, I start parsing with continuation keywords being string set empty. Not a colon is needed. String set is wait, if I say set make, like, is it like a pure function? So can I, like, because can I do this? Can I do that? Not exactly. Okay. Not exactly. String set. You know what? I will even put this into the standard library in the end. Because why not? Okay, so now when I'm parsing the inner value, so this is the new filter, right? You know what? I want to name that too. Filter. And parse one also. I like having names to my arguments. I broke the syntax. Oh. There we go. So now I want to add the continuation keywords, which is... So I need to string set, I need to have a union. Union of two string sets, which is the current continuation keyword. And the what can I continue if I have parsed that value, basically. Right? Which is going to be the string map dot key like. So I have the next dot next. Yeah, and I need to get the keywords that go out of that. Current node. No. Yeah, the value. Inner continuation keywords. Oh, and if it's this, then it's a hash set new actually. If I just opened the parentheses, which is maybe a hack. So I have the continuation keywords, and then I add all the keywords. Yeah. You know what? I just say next continuation keywords. How about that? So I need for the nodes in the rule set to also know what are the I guess just next keywords. You know. What are the next keywords that I can continue with? So this would be a string set. So by default, next keywords is string set empty. If I have this thing, then it's the same. Next keywords is node next keywords. If I add a first one, yeah, then I need to have the updated next keywords is updated next keywords, right? Which is going to be updated next keywords. I guess I can, yeah, sure. Let's just inline this here. So if the first one that I'm adding here is a value, and it's the original keywords, but if it was a keyword, then I say string set add keyword to the node next keywords. Down. Okay. It still breaks. Okay. It still breaks. Still is parsing this. Named. The comma. So like why? So here's what's happening, right? I'm parsing A is equal to B, and then I see a comma, right? Yes. I see a comma. And I see a C. Oh wait, hold on. This actually makes a lot of sense. I'm stupid. My syntax was incorrect. Like I was thinking that this is correct, but it's not, right? Because like inside the comma, this can only have the higher priority, right? But the named one has the priority 1. This must have the higher priority, is the thing, right? It must, because otherwise on the right side of the comma I cannot have like an equality. Although like it's still, yeah, and then it just shows the other bug that is present in the other implementation too. But yeah, this and then this works. Okay, never mind. We do have a bug, but it doesn't matter for the syntax that I was using for cast, apparently. I should probably write it down and then like, you know. to do, we have to do a bug if trying to do this, but with named rule having priority same as comma, like, yeah, right. But other than that, wait, no, hold on. Could not finish parsing. Peak is this. Yes. Yeah, and then I reset the continuation keywords whenever I go through the any filter, I guess. Continuation keywords. This, but only if. So this is updated, or inner continuation keywords, where inner continuation keywords is this. Takes clowns incoming. I was going to end the stream though. You can abort. You can tell them to abort. I'm going to fix this bug in 5 minutes and then I'm ending. Is OCaml harder than Rust? No. It is easier than Rust, but like for example, like Go is easier than Rust, right? But because of the lack of the features in Go, the writing programs in Go is more difficult. But learning Go is a lot simpler. You can do it in like 5 minutes because it's made for monkeys. Syntax is harder. Syntax is only harder for you because you are used to the C syntax, right? There's a like there are some people that are just used more to the functional programming syntax. That so the C syntax is like difficult. I don't know. Like once you're, it just takes time to get used to. Yes, if you have never tried the functional programming before. But yeah, yo, Cakes has arrived. I was telling that you should abort the raid. I was told that you are going to raid before you raided, because I'm going to end the stream in like 5 minutes. But sure, I will try to entertain you guys for 5 more minutes. So what's happening on this stream? Thank you for the raid. And when you're going to play my game, Cakes. But yeah, what's happening here is I'm making a programming language. I'm rewriting it from scratch. It was written in Rust before, and now I'm rewriting it in OCaml. Specifically, I'm working on the parser. The parser is extensible because I'm making a language where you can have your own custom syntax. So that's why the parser is not very, very simple here. So that's what's happening. And yeah. Yeah, you can carry the raid trade to the 3rd stream. All right, who are we going to raid? Who are we going to raid? So the inner continuation keywords, if next filter of the value is, or is it an optional one? It should basically be any, right? So yeah, I'm going to match filter, and if it's none or some any, then I just say string set empty, and in any other case I do that with. Oh, nobody's saying 5 cakes. Things have changed. Old era is gone. Okay, there we go. The test actually works now. Okay, I fixed it. So for those who are wondering about this, So we have the syntax rules, which are written like this. So this over here is the simple syntax, which can be used to like parse this code, which is kind of like similar to Lisp, which I use for tests. And then we have another syntax, which like is the actual syntax of the programming language, which looks something like this over here. So the syntax for the language is basically implemented in the language itself. By default, the core of the language has no syntax except for the syntax for defining new syntax. Yeah. So the syntax of the language is a library feature, and you can change it if you don't like it. For example, yeah. So this one is just syntax from scratch, and stuff. And then you can write programs. Let me just at the same time show a program with a syntax. Is it like in the untested? Syntax. Local syntax, right? So I have this example, right? So for in this example, we define a syntax call one with two, which is having basically a keyword call, then A, and then and then B, right? And then I can use this syntax, and it is going to mean calling both of these functions. And then this syntax is only valid inside of this scope too. So like it's not me just extending the syntax, it's also a scope, only a syntax that is only valid inside of the scope. So like this feature is supposed to be used for like embedding other programming languages in your programming language. For example, when you're writing HTML, and inside of HTML you have JavaScript, and then inside of the JavaScript you sometimes have HTML, like with those JavaScript frameworks, right? So that's what is allowing to have something like this. Or like, for example, you want to have a query to the database, so you can make sure that your SQL query is actually properly parsed by doing that, by using like by overriding the syntax inside of a scope, instead of it working just through the so like in Rust. So like usually you just have a string representing the SQL query, right? Or some other solutions, like in Rust, you sometimes have you write a macro which parses that, but yeah, it's just supposed to make this very simple to be used when it's needed. And it also makes me making the language very simple, because it's just very simple to change the syntax. I just move some definitions around and stuff. We support having some syntax scope, not allowing higher level scoped syntax. Yeah, it's called syntax from scratch. Although I need to have the like syntax from scratch basically gets rid of all the syntax that's defined in the outer scope, right? So you don't, so like following the syntax from scratch, you need to like populate the syntax again, right? And then I also like I didn't have it, but I plan to, right? To basically have, say, syntax from a file, right? From some path, right? So you can load a specific syntax, right? Which so you will say something like syntax JavaScript or syntax SQL, instead of like because you don't need to like do it manually, right? It is already defined somewhere. So that will override the syntax, not add to the syntax. Syntax as a library, yes, and that it's already how it is. If I try running this is the thing, right? So I am in the REPL of the programming language. std is the thing which has the syntax as a field, basically, and this is the syntax module. We do have syntax as a value already. I just didn't have the syntax to load and override this, but we will. Okay, trace, debug, and then I wanted this over here to be also a trace. Okay, this works. Everything works. Okay. Okay, let me just do one last thing, right? Because I changed the syntax from OCaml to this file in the simple syntax, but I want to do the same in the default syntax. So the default syntax is going to be also done very similarly. So I change this, right? So rule set is just parser rule set dot parse lines of, it's going to be the same thing. So this is the entire module. We just need to migrate all of these into the simple thing, right? So let's just convert it. Then of priority 0 is the unnamed value with priority greater, because this is a right associative thing, and then a semicolon, and then another thing, which is greater or equal, right? This is this. Next one is going to be statement, which is of priority 0. We have a value, which is of greater priority, and then a semicolon. So this is just a trailing semicolon. Then we have the use dot star, which priority 1. It is having keyword use, then the value, and then dot star. We'll code in different syntax, have cast semantics. So like in order to have cast semantics, like the way syntax works is like it's being like the custom syntax, you bind it to a macro which expands to some other syntax, and we do this recursively until it is done, until it like becomes the core syntax of the language which cast understands. So the core syntax is basically like the final form, which is being then compiled. So yeah, the semantics are still, I mean, you can define the semantics with a macro, right? And then your macros should be defined in terms of like eventually they should be rewritten into some core syntax. So if priority 1 is if condition then case else the else case, which can be equal, which means that it is right associative thing. Okay, then we have the pipe, This game has potential. Any plan to release on the mobile? It already works on the mobile, but we're not going to plan it like the first release is going to be the Steam release. We're currently looking for the wish lists. Thank you for trying out the game, though. Yeah. The game won the Bevy Gem. We know that it's cool. We are waiting for the wish lists, right? I don't know how much Cakes has on his game yet. Have info about the game in the title, but I'm not working on the game right now, right? I have it on the corner. But yeah, we're waiting for the wish list. We currently have like, I don't know, like 500 maybe. Yeah, I need to like, technically I need to work on the marketing, but I'm instead doing this. There you go. All of those 1000 lines in just 7 lines of defining the syntax now. If I did this correctly, then the tests will work, but they don't. Just if apply x, then a, else b. Expected if apply fx, else b. Wait, hold on. It is parsed correctly, but the error message says that it's not. Is it because I have the double equal again? Probably. I should replace all of the double equals everywhere. Should never use a double equal. But that's not the problem. But it says that it parsed the if, and then it says that it's expected literally the same. Oh, it's because conf. I have a typo somewhere. Over here it says conf, but it should be cond. There you go. The tests work. Driving ppx show on one type considerably slowed compilation on your camel project. Yeah, I guess deriving can can slow the compilation down for sure. Right, default syntax using rules file. And this is the simple one. We can also use, we can also like migrate the old one. But for now, this is good. I'm going to end here. Thank you guys for watching. Play the demo of our game, by the way. The game is also cool. Not the programming language that I'm making is cool. The game that I'm making is cool. Everything is cool. You should just check it out and give it a wish list. Wishlisted. Yes. Not even 4 hours. Well, I started late today, and I need to do some work. Yep. People work for 8 hours. Well, yeah. Well, I mean, I have work too, you know. I don't only stream. There's a Lisp person. She's making a game with Lisp. See you guys next time. Bye.